Hello everyone, my name is Ananya P. Temkar and I am a student from Sri Venkateswara College of Engineering. Today I shall be talking about applications of process scheduling in operating systems. In this video, I shall talk about what is process scheduling, importance of process scheduling, types of process schedulers, and different types of scheduling algorithms in operating systems. What is process scheduling? Process scheduling is the selection of process for the next execution in the CPU. Process scheduling is done by process schedulers. Process scheduling is important as it maximizes CPU utilization by quickly switching processes. It ensures that the CPU is not idle and is always executing a process. Different scheduling algorithms prioritizes processes based on different burst times and urgency. It maintains scheduling queues of processes such as job queues, which is a set of processes in the system, ready queues, which are the set of processes which are ready to execute, and device queues, which are processes which are in waiting, for an input or output device response. Types of schedulers. There are different types of schedulers in operating systems. Short-term scheduler or a CPU scheduler. It selects which process should be executed and allocates CPU to it. Long-term scheduler. It selects which process should be brought into the ready queue. It controls the degree of programming. It is also known as job scheduler. Medium-term schedulers. It is used for decreasing the degree of multi-programming. Medium-term schedulers can remove process from memory, store it on disk, and bring it back to continue its execution. This is done when the process has a longer burst time and requires and there are more urgent processes that needs to be executed, or it is done when the process needs a response from other processes such as input or output devices. Scheduling algorithms. There are different types of scheduling algorithms which prioritizes processes on different criteria such as burst time, arrival time, and priority. These are the following scheduling algorithms I shall be discussing in this video. First come, first serve scheduling algorithm. This algorithm executes the process which arrives first until it is finished. There is no interruption in this algorithm, that is, the process execution is not interrupted. The process scheduling is represented by a Gantt chart as given in this figure. Here we can see that there are 3 processes, and process P1, which is first in the order, is executed first for 24 burst time, which is the execution time. Then process P2 and P3 are executed as follows. Then we have shortest job first non-preemptive scheduling algorithm. This algorithm executes the process with least burst time until it is finished. This algorithm also has no interruption. Here we can see, according to the Gantt chart, that process P4, which has the least burst time, is executed first. Then process P1, which has the next least burst time, is executed next. Shortest remaining job first preemptive scheduling algorithm. It is similar to SJF, but process arrival time is also considered in this algorithm. This algorithm executes the process with least remaining burst time until another process with a shorter burst time than the remaining burst time of the current process arrives. When the execution of a process is preempted by another process, the remaining burst time is executed later. This scheduling process has interruption. Now let us look at the following Gantt chart. Here process P1 with burst time 8 arrives at time 0. Then it is executed until process P2 arrives at time 1 the process P1 is preempted. Since process P2 has burst time less than process P1, it is executed first. While process P2 has executed, process P3 and process P4 has arrived at arrival time 2 and 3. Since process P4 has less burst time than the remaining burst time of process P1, it is executed first. Then the remaining burst time of P1, which is 7, as one burst time was already executed at the beginning of the Gantt chart, is lesser than the burst time of process P3. Process P1 is executed first and process P3 is executed at last as shown below. Priority scheduling algorithm. A priority number is assigned to each process based on its urgency. The lower the priority number, the higher the priority. The highest priority process is executed first regardless of its burst time. Here we can see that process P2, which has the lowest priority number, is executed first. Then process P5, which has priority 2, is executed next. Then process P1, which is priority 3 but the highest burst time, is executed next because is executed next. Round robin scheduling algorithm. In this algorithm, each process gets a small amount of CPU time or quantum time queue. After this time has elapsed, the process is preempted and added to the end of the ready queue. The timer interrupts every quantum time to schedule the next process. Here in the following Gantt chart, the quantum time is 4. We can see that P1 is executed for 4 burst time, and then it is switched to P2 and P3. Since P2 and P3 burst time is 3, which is lesser than the quantum time, their execution is already completed. The remaining burst time of process P1 is executed at intervals of 4 quantum time. Thank you for watching this video. I hope you found this video informative and educational. Don't forget to like this video and subscribe to my channel. Have a nice day.